This is part 2 of Exam 2, example number 2. It was left off that V out was equal to minus 1000 VGS2. So now VGS2 needs to be found, which is VG2 minus VS2. The most common problem is that people forget to put in the VS2. So VGS2 is equal to VG2 minus VS2. VG2 is the node up here. If the current is found here, multiplied by the resistance 3K, that current is a minus GM1 VGS1 times 3K. Or sorry, the opposite branch would be 2K. All over the summation of everything, which would be 2K plus 8K, so 10K. Multiplied by 3K. So that's VG2, VS2. So VS2 is a positive, the current is going down, so a positive GM2 VGS2 times 2.99K. So now VGS2 is on this side and this side, so this one needs to be brought over here for VGS2. 1 plus GM2 VGS2 times 2.99K. This should have been VGA2 minus the positive, which is VS2, is equal to this quantity here, the minus GM1, which is 10 milli. So that is a minus 6 VGS2. And this is already taken care of here. So 1 plus GM2 times 2.99K is equal to a minus 6 VGS2. So multiplying that out, VGS2 is equal to a minus 0.02 VGS1. And VGS1 is the same idea. VGS1 is equal to VG1 minus VS1. And VG1 is this node up here. There's no sources up here, so this is actually 0. And VS1 is the drop across this plus the drop across that. So it's a minus GM1 VGS1 times 100. And then plus V sig. So again, a VGS1 and a VGS1, so combine them on the same side and then divide, and that gives VGS1 is equal to a negative V sig divided by 1 plus GM1 times 100. So this ends up being a minus 1/2 V sig. So now this value can be plugged in here and this value in here to give V out in terms of V sig. So I'm going to multiply all those together. So VO is equal to a minus 1000 times a minus 0.02 times minus 1/2 V sig, and V sig I can divide, and this whole quantity gives me a minus 10 volt per volt gain.